Good morning. Our project is titled Manufacturing Driving Design and Precision Machining of a Pin Tuber Padlock Core. This project was conducted for the course Advanced Mechanical Process BTT 3443 by Group 2 under the supervision of Dr. Masayu Benti Hassan. I will first introduce the background and the material selection of our project. Mechanical pin tuber lock are widely used in residential and industrial security systems because of their simple structure and reliable performance. However, the functionality of these locks is highly sensitive to micrometer level dimensional tolerance, which makes them a very suitable case study for engineering education. In many existing educational projects, lock designs are simplified or made from plastic prototypes, so they cannot present real industrial performance. Therefore, this project adopts a manufacturing-driven design approach, where manufacturing constraints are considerable from early design stage. Mechanical selection in our project focuses on manufacturability and mechanical reliability. The lock body uses stainless steel for strength and corrosion resistance. Brass is selected for the cylinder to encourage good mechanicability and smooth operation. Hardened steel and spring steel are used for the pin and springs to maintain accurate and stable elastic performance. Overall, the selected materials support precise mechanical and reliable lock functionality.
Hello everyone, I'm He Jiahui. Now let's look at the materials we choose for the project. We picked high-quality metal materials for the lock core and key. Why metal? Because metal is strong and durable. The metal we choose works well with CNC machining, laser cuttings, and heat treatment. This ensures the final product has sustainable performance. Using the right materials is the first step to make a reliable lock. And next, let's introduce the three core manufacturing processes we needed. First, CNC machining. We use this process to shape the lock core and the key. Second, laser milling, hybrid fabrication. This process helps us to make small and detailed parts. Second is heat treatment. After machining, we heated and cooled to the parts. Now let's move to the assembly process. We followed the clear step-by-step workflow. First, we checked all parts to make sure they meet the size requirements, and then we installed the key pins and the driver pins into the lock core. Next, we added the springs to keep the pins in place. Finally, we tested the core to see if it could open and close smoothly with the key. Okay, last, let's move to the testing procedures. It includes three procedures. First, functional testing. Second, dimensional inspection. And last, mechanical security testing.
Good day. This section presents our project outcomes, the manufacturing process, testing results, and the comparison with commercial locks, validating our manufacturing-driven design. Our process began with 304 stainless steel. Key process included CNC milling, turning, laser cutting, and heat treatment, ensuring industrial precision and efficiency. Testing confirmed high performance. Dimensional inspection showed 100% compliancy for critical features like pin length, Functional testing achieved 500 circles with 0% jamming and excellent shearing line stability. Compared to commercial locks, our design offers superior manufacturing ability, material selection, and precision. The only minor drawback is slightly higher maintenance costs, which are offset by its overall performance.
First, we use the laser cutting to cut the keys, but the first time the key cutting is so big, so we use a small one, and this is the final project. And this is the final project of the log. And the specific principle is that we use the key and wait a minute. Yes. So great. Yes, it's correct.
Good everyone, I am Wen Haojie. Now let's move to the final part of our project, the conclusion. I will recap our achievements, share future plans, and express my gratitude briefly. Our core achievements are threefold. We successfully developed a precision pin temperature lock core. The core deliverable of our project it was achieved was the manufacturing-driven design approach, ensuring the product is both designable and producible, and the final product meets industrial standards. While we verified the efficiency of the process-oriented method. Looking ahead, we will focus on improving security and efficiency. We will enhance the lock core's structural security for better anti-theft performance, promote assembly process automation to boost efficiency and cut costs, and integrate advanced anti-profiling functions to upgrade protection. To realize anti-PRE, we will explore advanced pin technologies like sports pins and serrated pins. They create force feedback and complex resonating lock pickers and increasing unauthorized unlocking difficulty. Finally, my thanks to provide merchant and testing facility and to Dr. Shanghai Dairy and Madam Mas Ayu for their professional guidance. This research was funded independently by our team. That's all for our project. Thank you for your attention.